Okay, I think we can start.
Sure.
So, hi everyone. So today we are starting a capstone project. So this week we will be working this week, and the second and next week we will be working on a capstone project. And some of you asked me to select a few projects and show you. And I thought of not selecting two projects. I saw that we have in the chat a few very active people who help everyone. And I wanted to ask them to present their projects. So these two people are Alvaro and Al, or Al, right? Al for short.
Yeah.
And
Hello,
Ninat. Hi, everyone. So I would like to ask you to present the projects you did for your midterm project. And yeah, so I guess you can start.
All right. So hello, everyone. I'm Alvaro. I'm from Barcelona, Spain. All my foreign friends call me Al. So you can call me that. It's perfectly fine. Well, I'm learning about machine learning because I want to change my professional career, and I find machine learning fascinating. And I'm very much enjoying what I've learned so far, and I'm really enjoying the course. So thank you, Alexei, for the opportunity. And since he asked me to talk about my projects, I will explain my thought process from choosing a data set and how I developed pretty much everything that was required. So here, sorry.
May I interrupt you for a moment? Maybe I also wanted to ask Nina to tell a few words about himself before we go to your presentation.
Of course.
Sure. Yeah. Hi, everyone. Am I audible?
Yes.
Okay. Yeah. So hi, I'm Ninad. I am based out of India, a city called as Pune. And so I have been into this IT for around 20 years plus. And I was working as a solution architect, wherein I started developing some solutions wherein I had a team of machine learning experts under me. And that piqued my interest. So at that time, I was totally new. I didn't understand what they were saying, but it was pretty cool stuff. So I thought, okay, why not give it a try? And then this course came up. So thanks, Alexei, for this great course.
Thanks for being here. So Al, please start.
Sure, thank you. So I will begin by explaining how I chose the dataset and my thought process about it. So up until the point where when we started the midterm project, we had only dealt with tabular data. And since the project was to be peer reviewed, I decided to work on a simple project that made use of all we've learned so far in the course until that point, and with a simple to understand data set in order to make it easier for the reviewers to understand and evaluate the project without the need of any background knowledge about the data set. So I have to admit that I wasted way more days than I expected finding a good data set, partly because I was lazy, partly because I wasn't sure what to do. But then eventually I found this interesting data set. Let me share my screen to show you. Wait, there it is. Wait, there we go. This is it. Can you see my screen? All right. So I found this speed dating data set, which I think doesn't really require any background knowledge of anything in particular. Let me explain the data set before we begin. The data set was acquired during a speed dating experiment. And the attendees would have a 4-minute first date with every other participant of the opposite sex. And the dataset contains many features, which contain the following info. There's questionnaire data gathered from the participants, such as demographics, dating habits, self-perception, etc. There are ratings of each of the attendees at dates in 6 attributes, which are attractiveness, sincerity, intelligence, fun, ambition, and shared interests. And finally, our target feature, we could say, is whether they'd like to see their date again. So sorry about that. Here's a quick explanation. You can see that there's a few
Can you enlarge it a little bit?
Sure. Oh, sorry. Yeah, I forgot. There we go. Can you see it now? All right. So like for instance, some attributes, they're not shown here. They're shown, I don't think I have any visual aid for this, but like for instance, some ratings such as being intelligence or sincere, they're on a 1 to 10 scale, but there's also like additional features which were categorical that contained the interval of that score. So like, let's say an interval of 1 to 4, then 4 to 6, 6 to 9, something like that. Those intervals were not regular. So like for a feature, the preset intervals were different than from other feature. But that's for some reason that was contained in the dataset. There's also more complicated features. For example, let's take a look at attractive, which is so this feature here is how the attendee rates themselves. There's attractive partner, which should be there we go, which is how you would rate your date's attractiveness. There's attractive O, which is right here, which is how your partner rates you and the event. There's attractive important, which should be, there we go, which is how important it is that your partner is attractive to you. And there's also the same for the partner, which is pref O attractive, which is how your partner rates attractiveness. So it's kind of complicated, but don't worry too much about it. It's just that I just wanted to, the main idea here is that each entry in the dataset contains both your info and the partner's info, which makes it a little bit tricky to work with, I think. I'm not sure if I did it right, actually. I made a few mistakes that I will talk about. But anyway, there's also a few, this is our the demographics info I was talking about, this like such as interests. So whether you like sports, exercise, dining, museums, art, etc. There are a few, let me check my notes. This is a target feature, which is match, whether you would like to see that person again. And this actually hangs on these two features, which is here is whether you'd like to see your partner again, and this is whether your partner would like to see you again. So obviously, this is like if both of these features are true, then the match or target feature would always be true. So I removed those two features from the dataset because otherwise it didn't make any sense to build a model because you could ignore all the other features. And I also removed those interval categorical features I mentioned because I thought they were redundant because I already had the numerical value for those features. So I thought they were unnecessary. I probably should have removed a few more things, such as this one, expected number of matches, like how many matches you expect to get, because I don't think they contribute much, but I left them. You could probably do many more things with this data set, but I probably lack the knowledge to know how to do more so with this. But well, let me explain now. With this, I hope that you understand the data set. So I will get into the actual project now. And so we begin with the exploratory data analysis. This is how I decided to import the intervals. You know, I already, I only chose to import some features because I already mentioned those that I left out. I also noticed that many, not a number of values were marked with a question mark. So I already added that sign, that character as a missing values possible character. So when importing the dataset, this was already taken care for me. So you can see this is like a sample. This is like the head of the dataset with only, I transposed it so it's easier to take a look at. And you can see it's got many features. It's got age, all these ratings, the field of which is what the attendee works at, and so on. And so here, let me begin with categorical values.
May I ask you to increase the font a bit more? There's
sure.
Yeah, somebody asked for that.
Sure, sorry about that. Here, let me.
Yeah, thanks.
Is this good enough, or would you like it to be bigger?
I think it's good enough. So please tell us if you want it to be a bit larger, and then I'll ask Alvaro to do it. But I think to me it looks fine now.
Okay,
Thank
sorry
you.
about that. So I just take a look. I followed essentially the same steps that we did during the course that Alexei showed in the video. So I take a look at the null values. I noticed that pretty much all features have null values. You can see all the truths here. And there's quite a number of them, like this particular one, or this one, or even this one. So I also take a look at the types. And I also clean up all the values. In particular, the field feature, which is the job of the attendee. There are 259 possible values, which is a lot. And I know there was also, Alexei did this in one of the office hours videos. He mentioned how you could reduce the number of features, of number of values in a feature. However, I did not enough time to do this. I had to turn in the project. So I wish I could have done that, because there were some jobs that were like, they only have like 5 or 6 people out of the thousands. And this particular field, this particular feature, the field feature, was the hardest to clean up. You can see here, there's law is duplicated with capital letter and lowercase letters. There's quotations. There are typos like this, language and whatever you would say this in English, etc., and so on and so on. So here, let me scroll down. This is a very long Jupyter notebook. Sorry about that. I started cleaning things up. I removed all these additional characters. I removed the white space, and I also added this little function that counts how many of these positions are, so to make it easier for me to understand. And I also ended up joining a few of them together because I thought they were the same job or the same profession. So this is all my code in order to do this. It's not complicated. It's just the same code that we used in the class, except it's tailored for my specific use case. And that's the one feature that took the most work. Then the other features, not so much. For instance, race, there's only these possible values, which are actually 5. Sorry about that. And finally, we end up with numerical features. And this is where I did probably the biggest mistake of all, which is that I did data snooping. I did not prepare my validation framework. I did not do my splits beforehand. Which actually can alter the results, because in order to fill in the null values, I calculated the means of all the features, and I filled up I fill the missing values with those, because I thought that would be the most relevant value possible. And if I had chosen the mean of only the trained data set, that probably those values would have been different, maybe similar but different, and that could alter the training of the models. But that's what I did. So I'm going to show you so you can learn from my mistakes. And so, wait, I forgot where I was in my notes. Let me check real quick. There we go. So this is just filling in the values, and that's it. That's nothing too fancy about it. And then this is where we actually start the exploratory data analysis, where we take a look at the match rate and risk ratio of the categorical features. I probably should have added the amount of matches as an additional column in order to understand better the difference and the risk ratio, because I think it's a little hard to understand intuitively. For instance, here in the field value, we can see that we have 22 people that work in the acting field. They have a difference lower than 0, which means that they are more likely to match with others, but the risk is completely 0, which I don't know what it means. Or I thought it should be a little higher, but anyway, maybe they all matched, which I didn't check. So that would have been helpful to add here in these frames, these data frames, sorry. This is a very long info. There's also the mutual information between these categorical features and the match, which all the values were pretty slow. Except maybe for field, which is a little higher than the others, but still very low values. And finally, we've got correlation. Correlation of all the numerical features. We have a lot of features. So what I did for Visual 8, I created a heat map, which can be seen here, which is, you can probably cannot see anything at all, but I zoomed in here a little bit. And there are a few interesting things here in the heat map. Let me zoom out so you can see it better. And we can see that there are a few interesting clusters which are more lightly colored on the edge of the triangle. And those would correlate, for instance, all these features which are, let me zoom in. Wait, why is it not working? There we go. Being sincere, being intelligent, being funny. So these are the ratings that your partner gives to you, which are correlated with also the same attributes that the partner gives to you. So that would make sense, right? So if you find someone funny, you are more likely to find them intelligent, and if you look up the values, then that matches. The same goes for this particular cluster, which belongs to what the attractive. Sorry, I was wrong. I keep mixing this up. This at end with an O is the importance that is the rating that the date gives to the attendee. So the rating that your date gives to you, and partner is the rating that you give to your partner, which also makes sense. It's very similar. There's also this particular cluster here, which is it belongs to the like feature, which is one of those kind of weird features that maybe I should have removed. It says here that if you find your partner attractive or sincere or intelligent, you are more likely to like them, which makes sense. And we can see here they are highly correlated. Maybe not as much as I expected, but they are. And that's pretty much I think that's all the interesting info we can gather from the heat map. Let me go back to the notebook. So we finally end up creating our validation framework and one-hot encoding. Remember that I should have done this step beforehand, doing the exploratory data analysis. I followed the same steps that we followed in the videos. And we finally go to creating our models. And I chose to create a decision tree, a random forest, and a gradient boosting model. I did not do a logistic regression model because I thought it was kind of simplistic. I probably should have included because it wouldn't have been that much additional work, and maybe I would have found a surprise on its accuracy. Who knows? But I did not do it. So I'm already. I still got a little bit of time. So I'll explain this. This is kind of well, this is a default tree. We can see here it gives me this particular score. However, decision trees are very likely to overfit. And we can see here if I export the tree, you can see it's a very big tree. It's not limited or capped at any particular depth. So this is just a default tree, and you can see it's very big. But it's not very accurate. It's only at 0.63. So when I limited the tree, it keeps going. When I limited to the max depth of 2, I found that the validation ROC-AUC score, I always forget what ROC stands for. I think everyone forgets that, but area under curve score is of 0.76. So by limiting the depth, we can have a more accurate model. So I did the hyperparameter fine tuning, and I found that, let me go quick here. I wrote my results here. Yeah, with a max depth of 4 and a minimum sample sleeve of 200, we find that I get the highest score of all. Here's the heat map that shows it, and the highest score belongs to this one, which is 200. I'm not sure. Can you see my mouse cursor on the screen? Okay. So this would be the highest one with area under score of 0.811. And well, if you want to take a look at the tree, it looks like this. It apparently, in order to be successful in a speed dating event, you have to be either funny or attractive. So maybe that's useful for you. I don't know, but it's interesting to know. So when I did the k-fold cross-validation, I got very similar values to what I got before. You can see them here in this row, and with a very little standard variation of 0.01 almost. So I think it's consistent in that regard. Then I did a default random forest model, which gave me a slightly higher score of, I believe it was, wait, where is it? Wait, I don't have it here. 0.84 I've got written down, but where is it? 0.84. That was with, wait. Oh yeah, I skipped it. Sorry about that. Yeah, so this is the random forest model, the default one, which has this validation score of 0.84. So I started fine tuning, and I did the fine tuning on the same hyperparameters that were shown in the videos, which are number of estimators, depth, and minimum samples per leaf. Sorry. And once again, we keep exploring. We do essentially the same steps in the video. We show the same graphs. And the best result was with 180 estimators. I have a slightly higher of almost 0.85 score. Then we keep fine-tuning. These are the depth of the trees in the random forest, which because I was interested to see how deep they were. I fine-tuned the depth, and eventually I found out that with a max depth of 15, with slightly less a slightly smaller number of estimators, I got an even higher AUC score. And finally, we go with, well, here you can see the graph. It's a huge mess. Sorry about that. I probably should clean that up. And also here is the minimum samples leaf. Sorry. Which I fine-tuned, and I found out that I did not have any need for fine-tuning because the default value of 1 gave by far the best result, which you can see here in the graph. It's the top line. So that's pretty much it for the random forest. I also did the k-fold cross-test validation. Once again, here you can see the score, 0.85. I did the k-fold cross-validation with the same results pretty much. And as well, the standard deviation is a little bit higher this time at 0.015, but still pretty small, I think. And finally, the gradient boosting model, which once again, I do a default model. It turns out to have a very high score. Then I fine-tune everything. I find out that increasing the number of boosting rounds to, I believe 50 it was, here, let me check, yeah, 50, gives it an even better validation score. However, I think it's pretty much overfitting, I'm pretty sure of it. Then I also proceed to fine-tune the learning rate, max depth, and minimum child weight. However, I found that the default values were giving me the best result. Here you can see some graphs. Let me scroll real quick here. This is essentially a string. I'm not very sure. This code is kind of messy because I had a lot of trouble trying to parse the results from XGBoost. So this is why the code is so long and so I think inefficient. But anyway, by testing all these values, I found that the default value for the hyperparameters, other than number of boosting rounds, it was the best possible value possible. And I end up with a model that has a AUC score of 0.868. And once again, after doing k-fold cross-validation, I end up with very similar results here, once again, with a very small standard deviation of 0.01. So I finally tested with test datasets, test split, rather. And so this is the result for the decision tree, which is this one, 0.82, for the random forest, 0.85, and the gradient boosting model, 0.87. So I concluded that the gradient boosting model was the best possible model, which is the one I chose to deploy. And here you can see an explanation of how my deployment process was. My main problem was that I was working with Conda, and Conda is kind of big. And when you try to generate a Docker image with Conda, it ends up being huge. It actually, well, when I managed to make a smaller version. However, it uses it's called a multi-stage build, which is like you build a first image and then you build a second one from things of the first one. But it's not supported by Amazon, so I couldn't use it when on Elastic Beanstalk. So I had to use my big one, and the default instance that Elastic Beanstalk gives you in the free tier did not work, so I had to increase it, and it's a huge mess. So now that for the homework of this week, I've learned how to use Docker for testing, I will probably do that because Conda is very nice to work with locally, but for deployment, oh man, it's not nice. Sorry, these are the steps: how to run the code, how to run the Docker image. I provided 2 files in order to build the multi-stage build and the Docker and the regular Docker file, and how to deploy it on Beanstalk and how to change the instance in order to for you to be able to run the code. And that's pretty much it here. Also, because the running the instance was pretty expensive, so I only tested it for a few hours. I took the screenshots, and this is how you could test it, and you can see the result of how it looks like in VS Code when you run it. And I also this particular link, the how to build to create multi-stage Docker builds, I think it was very interesting, so I added here in my documentation. So that's pretty much it. Let me look real quick to my notes because I think I wanted to mention something else. Yeah, the only thing I want to mention is that I had to review a few projects, and I was very impressed with many of them. I was particularly impressed by one, which I didn't fully understand the dataset because it was advanced, but the way the code was structured and everything was super clean. And my folder is a huge mess. I probably should include a separate Docker folder with everything that you need for the Docker deployment, rather than having everything in a separate, like in a flat structure like this. This one you can see here that says cloud. This is only the images for the README. So yeah, those are the 2 lessons I learned. Don't do data snooping. Clean up your code and try to learn more about statistics and exploratory data analysis, because I think it's very important in order to understand the data set and being able to make a better model. So that's it. Thank you very much, Alexei, for the opportunity, and I'll let Nina talk.
Yeah, thanks a lot. Thanks for showing us, and thanks for also talking about mistakes that you did. Do you, by the way, remember the project that you reviewed and you liked it?
I actually sent a private message because I found I don't remember. I don't have the link, but I know that the name of the student is Christian. That's all I know. Sorry about that.
Okay.
Oh yeah, yeah. I have it here. Let me, if it's okay, I will share it with you here on the. Let me share it to you here on
Zoom,
on Slack.
On Slack, okay.
There you go.
Yeah, I'll also put it to YouTube. Yeah, thank you.
Sure. This project was super impressive, so I really enjoyed looking at it.
I just shared it in live chat.
Mm-hmm.
Yeah, thank you.
Thank you.
Ninad, you want to do it?
Yeah, sure. So yeah, thanks, Alexei, and nice presentation, Al. So let me try to share my screen and take you through what I selected as my project and then how I approached the problem. So like Al mentioned, I also spend a lot of time going through many data sets. And so there were some very useful links that Alexei had shared, out of which this UCI machine learning repository is the one wherein I found a lot of interesting data sets. And so what I used to do was, before selecting the data set, so apart from the problem statement, because there were a lot of other problem statements that interested me, like there was one from IBM for attrition and few others. But what I also looked at was the data size. So because some of the data sets were very small, and then it didn't make sense for me to go with that and then trying to not have proper results. So I ended up selecting this bank marketing dataset, wherein I also did not find anything much on Kaggle and anywhere else. So I wanted to explore it right from scratch rather than having a lot of things which people had explored already. So this dataset is about a Portuguese banking, like Portuguese bank. And so what they used to do is that they had called their customers to collect a lot of information. In their conversations with the customers, they used to encourage them to invest with the bank in terms of a bank deposit. So this is what the data set is, and the reason this was interesting to me was like basically we know that all people take loans, right? And so for banks to get that money, this is what is one of their key source of income. So now they may have thousands and millions of customers. So how to choose whom to call? So it would make better sense to try and find out which are the customers which would probably invest into the term deposit and make the calls only to them, so that you spend less and acquire more. So that's what the data set was. And so let me explain the notebook. So the data consisted of customer information in terms of like the age, what job the person did, whether he was the person is married, not married, what type of education and all, whether the person had taken any housing loan or any other loan. The other information in terms of previous marketing campaigns, how did like when it had happened, how did it go, when was it done last time, etc. Few other things, what was the outcome of the previous marketing campaigns, how many contacts were performed for the same customer, and so on. And some other social and economic attributes for so these are more generic attributes for the customers. And the outcome was whether the customer subscribed to the term deposit with the customer after having made the call. So this was the data. So I started with importing our basic libraries in terms of NumPy and scikit-learn. And I also used grid search for the parameter, like hyperparameter tuning. And I used some pre-processings, which I will explain. So after loading the data, the first thing I did was, as part of EDA, I split the EDA into two parts, basic and additional. So basic was wherein I wanted to find out some basic things which I would do on the whole data set. And then I would split it across train and test. And to avoid data snooping, the rest of the EDA I would do only on the train data set. So in the basic EDA, this was more of a data check, whether the data is fine, whether the like the numerical and categorical features are correctly classified, because in one of like some of our lectures, some of our exercises, we saw that although something was categorized as an object, it was actually a number. So I wanted to check this thing, to check for any missing data, impute that, to see if any of the numerical data had extreme high values. So we have also seen some examples wherein null values were represented by an excessively high number. So although it may not come up in is null, but still it would be a null, right? So and then to see the cardinality of the target feature, cardinality of the categorical features, and the distribution of the target feature, so that I could then decide which scoring mechanism I would use. So that's what I started with. So first I had a look at all the like a sample, wherein I saw, okay, what do the values look like and whether they have been categorized correctly as numeric and categorical. Then looked for missing data. Fortunately, there was no missing data. Then I looked at the numerical and the categorical columns the way I explained. So first I checked whether like what's the cardinality of the categorical features, and whether there were excessively high numbers in the numerical feature to fill for NaN. So I didn't see that there was any such pre-processing done as part of the data that was shared by the bank. Then I looked at the categorical features, whether they had too many distinct values, because if they had, then when using one hot encoding, we know that for every value of the categorical feature, it would then create one new feature. So that would have expanded the overall data set extremely high. So I had a look at that. So it was manageable. I just had a look at, okay, what different values and what was the count for each of the categorical feature to try and get a sense out of it. And then I had I checked the distribution of the target variable. And here we can see around 88% to 12%, or 89% to 11%. So meaning we cannot use the accuracy as the score. So I decided to use ROC AUC in the evaluation later on. Then I also noticed that there were a lot of unknown values. Okay, so in many of the categorical features, there were unknown values. So I assume that, okay, unknowns could be like nans, like they don't have the information, so they have put the category as unknown. So I just wanted to check whether if I drop all those, will it make sense, or it is going to eat up too many records from my data set, and hence it doesn't make any sense. So I saw that it took around 35% of the data. So obviously it didn't make any sense to remove this data. So I kept it as it is. Then I looked at the distribution of the different numeric features, because like I was going to use logistic regression, and like we had seen in one of our exercises wherein we could use the log transformation so that we reduce the long tail for the target variable. So I thought maybe similar thing also applies for the features. So I just wanted to have a look at what is the kind of distribution, because most of the algorithms, what I read, work better if the distribution is close to normal. So I just wanted to check. So in this, I saw that these duration, campaign, p-days, and previous, these are very skewed, whereas the others are not so skewed. So I decided, okay, let me check what different transformations will I be able to bring them closer to normal. Now, I don't know when I had a peek at this, would this come under data snooping? I am not sure. So, but now rest of the EDA, which I did, I thought, okay, now I should first split the data to avoid any data snooping. So I split the data into 70, 20, 10. And then I just checked after splitting what was the distribution, because I should not have, let's say, the validation having a different distribution than the training, and hence not get the results right. So in one of our later exercises, Alexi had also explained that in the train test split, we also have the option of stratified. So, but by the time I did this, I was not aware of that. But luckily, I had checked the distribution, so which looked fine. Then I deleted the target variable, and then I used different pre-processing available in scikit-learn. So obviously, I didn't know of them before. I just Googled and found few. So quantile transformation is one. And then there's another called as power transformation. So I applied these on the 4 features wherein the distribution was not very great. And I can see that the campaign and duration are getting close to normal, but p-days and previous are still not, like they're still skewed. So I tried both these transformations, quantile and power. And then I thought, okay, because previous and p-days, they're not getting normally distributed by these two, let me try the logarithmic transformation. So I tried these and I found slightly better results. So I thought, okay, let me use this log transformation on these 2 features, power transformation on the duration and campaign. And the other features where the distribution was okay, I said, okay, I don't need any transformation. Then I looked at the feature importance using the mutual information score for this set of features for the categorical features. And I saw that these last 4 features, they don't contribute much. So I thought that, okay, when I now do the actual model training, one of the experiments would be to drop these features and see how different the score is compared to the whole data. So this was one observation. Then I looked at the difference and the risk ratio that we had learned in our telecom data set. So similarly, I looked at that. However, to be honest, I didn't do much inspection or insights into this. I just did this but there was a lot to do. So maybe I didn't spend more time in trying to understand these values. So maybe I'll try to do it later. Then I did the correlation for the numeric values, and then I chose the absolute value and found that most of the numeric values contribute. Like, so they have some correlation with the target. They have a lot of correlation, although these have less, but most of them have. And I then also checked the correlation amongst the features, and I found a few features which seem to be correlated to each other. And then I noticed that these seem to be those social economic context attributes. So I thought, yeah, maybe they make sense. They are really related to each other. But other features are not that related. So that was my conclusion. So then I started with the base model. So for the baseline model, I used logistic regression. I used one-hot encoding using the Dict vectorizer. And on the whole data set, I got an ROC AUC score of 9294 or 0.9294. And in one of the what you can say, as part of this documentation provided for the data, it was indicated that one of the feature, which is duration, you would know only when you make a call. And when you make a call, you obviously know the results. So it was recommended that you should not use duration if you want to have a realistic model. So then I thought, okay, let me also see what is the score by removing the duration, because these are realistic data that we would usually get. And yeah, so this was less than with the duration, which makes sense. So I said, okay, this is what I am going to use as my baseline. And then I created one, what you can say, a list to store all my experiment results. So I would store which which algorithm I used, what did I do, and what was the score, so that later on I can compare. Now I started with improvement over the baseline by doing some experiments using the logistic regression. Then I would select the best experiment, do the hyperparameter tuning, and similarly I would do a similar thing on decision tree random forest XGBoost. So the experiments that I did was like from the previous EDA, because I saw that there are some distributions are not great, and because like linear regressions and other machine learning models also perform well when the scaling across all the features are similar. So I thought, okay, let me also try like what is the effect of scaling on the score. Then check dropping features from EDA as well as dropping one feature at a time, and dropping multiple features at a time. Okay, so I tried all this. So I started with standard scalar. So let me scroll. I'll just show the results. So I tried standard scalar, min-max scalar, the polynomial features. So I can share this. So standard scalar scales to have a standard deviation of 1 across your column data. Min-max scalar will take like range or distribute your data between the min and the max. So basically, you will get the result between 0 and 1. And we already know about the logarithmic transformations. There are few others you can use for scaling, but at that time, I did not have the time to go through all. And then I also use the polynomial transformation, wherein it's like says sometimes what happens, the output is not linearly related to your features. So sometimes it's like squared or cube or a combination of two features and so on. So for that, polynomial features is useful. So I thought, okay, I will try that. So I ran all the scores through this for all these polynomial and all. And what I found out was min-max scalar and standard scalar performed better than the baseline, while polynomial did not. And min-max had the highest score. Then I checked what is the effect of dropping the features, which I found in the EDA to not have a lot of correlation. So as a result, I saw, okay, let me see. Yeah, sorry. So I also did some more transformations like the log transformation on previous P days. And I did some more combination of standard scalar plus log transformation and so on. And in the final results, what I found was that min-max scalar was the highest, and the P days using the logarithmic transformation was good. So I thought that, okay, let me choose these two for my future experiments. Yeah, so then I did this. I had a look at the coefficients. So these were very small numbers. Some of those were small numbers and some indicated large numbers, but I'm not sure. I was not able to interpret those. And later on in some of the reading, I also understood that if you do some transformations, then it also has the effect on coefficients. I'm not sure whether that's a correct interpretation or not. I'll study more. So then I did dropping the features from EDA, and I could see that the score does not change much, meaning the EDA conclusion was correct that these features did not contribute much. Then I started by dropping one feature at a time, and I found that like basically the results were better than the min-max scalar. So it improved. So what I did then was I tried to check which are the features which contributed better. But then I noticed that the difference in score is not that great. So although there's positive impact, but it's not too much. So I thought that, okay, if I combine the features when they were dropped individually, because they the score was good, if I drop multiple of those, will it be even better? So I basically, what I did was I used this what you can say function. I wrote this function to create a combination set amongst those set of features, and then I ran this to check the different evaluation, and I found that the combination of dropping multiple features increased the score even higher than a single feature. So in that, I selected the topmost feature, and then I did the hyperparameter tuning. So for that, I used the grid search. So finally, the conclusion was using logarithmic transformation on p days had helped me, and using the polynomial transformation had helped me. So I used that, and for using grid search, basically what happens is it also provides using k-fold, or rather kind of a stratified k-fold, wherein you don't have to do the train and validation split. So that's the reason for grid search, I use the full train copy. I did not go with only the train because then I would not have used the validation data and it would have used even lesser data. So I used this and I got this set of results which I saved. So I didn't go through this too much at this time because I had other algorithms to verify. So I did all this parameter tuning and saved all the results into a file, which I was going to look at later. Okay, so let me skip. Then I did a similar thing for the other algorithm. So I used the decision tree. I saw the score. The score was very, very bad. And like Al also mentioned, because decision trees, if you have an unlimited depth, they have a scope, like chance of overfitting. So I checked, okay, whether they are overfitting. So I tested what is the score on the training, and yes, they were in fact overfitting. So I chose a depth of 4, and then looked at what was the score of training versus the validation, and then I found that then there was very little difference. So I said, okay, this is what I will use as my baseline of decision tree, and now start comparing. So then I started, I had a look at, okay, which were the features that the decision tree used. And then I started doing the similar experiments. Okay, so I will not, because we have limited time, I will just skip this, and maybe later if I have time, I will come back to this. But most of the experiments in decision tree were lesser, result were lesser than my baseline with logistic regression. So that is one of the thing I noticed. However, when I used polynomial features, then the score was higher even than the logistic regression. So what I found that not all transformations will give similar results with different algorithms. So like different algorithms may perform better with different transformations. I didn't know that before. I thought that they would perform similar. Yeah, so then I did all the similar testing, like drop one feature, drop multiple features, and so on. So let me skip to before. Yeah, And so here also what I found that deleting multiple features had scored more compared to deleting one feature at a time. So I chose the highest scoring combination, and because none of the other transformations had helped, I did not apply any other transformation but I chose only dropping the features. And then I used basically I used the grid search CV to find out the hyperparameters. Then I did the similar thing for random forest. So again, I checked the score compared with logistic regression. Again, it was lesser than the logistic regression. Then I did a similar set of tests of different scaling, standard, min, max, polynomial. And I also did power transform on campaign. And I found that the polynomial was the best result for random forest amongst all the other random forest results, but it was still lesser than the logistic regression baseline score. So then I did like dropping one feature at a time, dropping multiple features at a time, right? And then I found that when I drop multiple features, that's where the score of random forest was now better than my baseline of logistic regression. So again, I used grid search for the parameter tuning, saved all the results. And then finally I tested with XGBoost. So again, XGBoost, similar story. And so unfortunately, actually, I spent a lot of time retrospectively, meaning I did not have this polynomial transformation, min-max transformation knowledge before. So I ended up doing all this. And then while searching something, I found standard scalar and all. So I redid my entire exercise, I don't know how many times. So for next time, I would start with all the transformations and then go in a systematic way. So in XGBoost, what I found was basically I checked the validation score and training score, and found that the validation score was decreasing. So I thought, okay, I will check how many number of rounds I need to basically train in order to make some sense. So from that, I found that if I use the iterations as 3, that's where the score was better, and later on it was reducing. So if you see, it is increasing up to 3 and then it is reducing. So I said, okay, I will use this as my baseline for XGBoost. And then I started with my experiments of doing the dropping of the feature as per EDA, doing the different transformations, min-max scalar, standard scalar, polynomial, dropping one feature, multiple features. So usually the way I did was, before dropping features, I selected which transformation helped. And the top transformation is the one I started using for dropping features. So that way I was like incrementally getting better results. So again, here all of the features helped. Like whenever I used to drop a feature, it was actually increasing the score. Then I decided to also test dropping combination of features. But with XGBoost, I didn't get similar results as the other algorithms, meaning dropping one feature or dropping multiple features did not make a lot of difference. So I just selected the top result, and then I did the grid search to find out the parameters. So after having saved all the parameters, then I loaded all those parameters across from all the algorithms, and these were the different number of results or experiments that I did. And then I chose the top 4 from each of the algorithms to see, okay, how do they look in comparison with each other. So I could see that the XGBoost was the top, followed by random forest, followed by logistic regression, followed by decision tree. So then I had a look at the XGB, and I found that the XGBoost, most of the experiments were even higher than any other, like the second most even, which was the random forest. So that's what I decided. But now I wanted to also check, or rather I wanted to select the combination or the parameters which also had the least standard deviation. So for that, I use this Plotly. Okay, so because in Matplotlib, you actually don't get to know what's the actual value. So in Plotly, if it's kind of an interactive graph wherein I could actually also see the results. So I use this, and in this I found that so this was the score which has the least deviation. So which I found as the entry number 241. So from that, I found out what were the parameters. And I said, okay, this is what I'm going to use for as my best model, as my final model. So I did a final training, and I just wanted to check how the results look like, and do I need to like what range of numboost should I select. So in this, what I found that, so let me just scroll down. So again, I use Plotly. So here I found out which is the number of iterations where I got the maximum AUC. So I saw that, okay, 335, it had peaked, and then it had gone down, and then it used to increase. But this increase was not very high. So if you see, it increases and then it stabilizes. So the more number of iterations we perform, obviously more number of resources and CPU it will take. So I chose this 335 because it gave me better result with less number of iterations. So that's what I decided to train my final model with. So I did the final model, like just tested the scores with validation and with the training to see if there was overfitting. So it did not have overfitting. Then I created this function so that I could get all the different metrics like precision, recall, F1, and all accuracy, AUC. And I got all the results and then plotted everything. The main intention was I wanted to find out what threshold should I use, because we all know that obviously we will not get like 0 false positives and false negatives. So we will always have some false. So what threshold gave me the best results? So that was the intention of drawing all these graphs. And what I did was I plotted false positive versus false negative. And I wanted to select a threshold wherein I would neither have a lot of false positives or false negatives. Right. So I chose this 0.32 as the threshold that I would use rather than 0.5 as the threshold for the final classification. So that's what I did. And then I had a look at all these different parameters, like all the different graphs. So because we are short of time, I'm just skipping this. And then I also checked the precision versus recall, wherein again at a threshold of 0.32, they were crossing. So I decided I would use 0.32 as the threshold. I don't know whether that is a correct decision or not, but that's what I felt logically. So that's what I did. And then I did the final training. And then I evaluated against the test data. And I got a 0.81, which was higher than what I had got on my training and validation. So that's my notebook. And so this is the repository wherein I have shared all the information. So explanation of all the files and folders. So I created different folders for Docker and cloud and all, like Al mentioned, so that whoever wants to do it, they don't have to copy certain files or it's not a clutter. So yeah, so that's more or less it. I used virtual env because even I found some problem with Conda, and the XGBoost was not getting installed, in fact. So almost towards the end of my project, I was struggling to get my environment working, but yeah, luckily I got it working. And then yeah, I have all these steps for deploying, and I deployed it on Heroku. And if I test it, it's still working. So
still deployed. It's still on Heroku.
Yeah,
cool.
it's still deployed on Heroku. And the good thing about Heroku is like it will go to sleep if you're not using it. But the first time, like when you try to access it, it will wake up and still it will give you the results. So you don't have to shut it down or anything. It will wake on its own, and it will also save you the seconds while it is not being used. So that's one good thing. So yeah, Thanks, Alexei, for giving me the opportunity.
Thank you. I am quite impressed by the depth of your exploration. That's like you put really a lot of effort. That's really cool. Thanks for sharing it with us. So I already shared the link. It's in the live chat, and I put it in the description. Yeah, I think there are some questions that I need to answer. So just one moment. Let me share my screen. So I will not keep you for long, just to tackle these questions quickly. And probably for you too, it will also be quite interesting. So the first one, are we going to tackle Kubernetes and TensorFlow serving and Kubeflow and KF serving? Yes, we are. And yeah, actually the last one. So let me just tackle this one as well. Okay, could you give us a breakdown of what is left of the course and what we're expected to finish? So let me do that. Yeah, so while Ninad was presenting, I did this like a quick sketch of what is still left to do. So right now, today, we're starting with the peer reviewing, with capstone project, and then there will be peer reviewing. So for capstone project, we will have 2 weeks to, and I think one thing I didn't mention, I forgot to mention, was this serverless homework. We still have till this Thursday, right? So capstone project starts today, and we will have 2 weeks, and then we will have 1 week for reviewing the project. I am not sure this time that we will be able to extend it, because in many countries there will be Christmas break, which starts, I think, if I go down to December, so which starts on the week when we should finish the peer reviewing. So I'm not sure how flexible we can be here with capstone projects. So please try to finish before the deadline, because I'm not sure we will be able to extend it. And yeah, so the reason I shuffled things around a bit is because of that. So I know that many people will have vacation, will have holidays on Christmas break. So that's why we should focus on the capstone project right now. So there is that. You should, by now you probably get an idea of what is expected, because we already did this midterm project. And I hope you got inspired by the 2 presentations we had right now. Then in terms of other things, so Kubernetes and Kubeflow will still be there. So for Kubernetes, I will try to record everything this week and make available. So if somebody wants to use Kubernetes in their capstone project, you should be able to do, hopefully. So I'll try to do that. But the homework for Kubernetes, I'll publish the videos now, but you will have a lot of time to finish it. So actually, like, let's say if your Christmas break is end of December, then like, let's say the first week of January, you can spend on solving the Kubernetes homework, or however you prefer, because I know in some countries, the break actually starts, on 31st, and then it finishes like, I don't know, on 10th of January. So I know in Russia, for example, it's like that. So yeah, so you're free to choose how exactly you want to spend your time to do Kubernetes homework. So for Kubeflow, setting up Kubeflow is really difficult. So if you're really motivated, you can follow the session, the videos, and do that. But I will not have you do the homework. So there will be no required homework, only optional if you want to practice Kubeflow. So for that, yeah, so there will be something, but no graded homework. Then also I promised a 3rd project. So for those who were a bit behind with the midterm projects and didn't have time to finish it for various reasons. So we will have a 3rd project, or if you just like projects, you can also do that. So it's not like you have to do only 2 out of 3. You can do 3 as well. And for the 3rd project, we will start it. Well, officially, we will start it on the 10th of January, but of course you can start it earlier, because it will be exactly the same as midterm or capstone project, just a different data set. And then we will have 1 week for peer reviewing it. And we should finish the entire thing, the entire course by the 31st of January. So by the end of January, we should be done with the course. And then there is this last thing, article. So article is just you take a topic that we haven't covered during the course, and you just cover it and write a short article about this with code and so on. And yeah, for that, I haven't really figured out the logistics yet for that one, but this is something I want to prepare now. So you have all this time, like December and January, to work on an article. So if you want to do this, this is, of course, I didn't mention that it's optional. So you don't have to do this, only if you want. And you'll have 2 months on that, basically. And just to remind you that to get a certificate for the course, what you need to do is to finish 2 out of 3 projects. Yeah, so that's the main requirement. Yeah, and the article is optional. You will get some extra scores for that as well. Yeah, that's roughly the plan. So if you have any questions, we can talk about that in Slack. And let me quickly check. Yeah, so there was one more question that somebody has trouble. Let me share my screen again. Yeah, so I'm struggling to run Python script with TensorFlow and TensorFlow runtime. I think you mean TensorFlow Lite runtime on VSL with Ubuntu 18.04 with Python 3.8. So what I would suggest you to do is try Python 0.7 on this Ubuntu. Either upgrade Ubuntu to 20.04 or downgrade your Python to 3.7. So because I'm on my laptop, I have Ubuntu, like the exact same setup, and Python 3.8 doesn't work. Or run this in Docker. So like if you run this in Docker, you don't have any problems. But if you really want to run it on your host machine with this Ubuntu and this Python, you have to either upgrade Ubuntu or downgrade Python. So that's it. So if you have any questions, yeah, feel free to ask in Slack. Thanks again, Ninad and Alvaro, for presenting your projects. I'm sure many people learned a lot from your presentation. So thanks a lot. And yeah, that would be it. So
thank you for the opportunity.
Yeah, please enjoy your capstone project.
Bye-bye.
Goodbye. Bye, everyone.
Bye, everyone. Thank you.